Hi. This demonstration is determination of the liquid limit and the plastic limit in fine-grained soils, ASTM D4318. Liquid limit and plastic limit are water limits at which the behavior of soil begins to change from either a semi-solid to a plastic state or from a plastic to a liquid state. And we use this information to predict shrink swell potential in soil, and we also use it to help classify soil according to the Unified Soil Classification System. In order to perform the test, we need a few things. We need distilled water, we need some fine-grained soil passing the number 40 sieve, we need some moisture content cups, and we also need devices for performing the plastic limit test and the liquid limit test. Let's start with the liquid limit. The liquid limit is defined as the moisture content of soil at which it starts to behave in a liquid manner. And we perform the liquid limit test using a liquid limit device, which consists of a small brass cup, a crank with a cam that raises and drops the cup from a height of 1 centimeter, and a pedestal. So here's how we do it. We're going to take some soil and we're going to mix it up with some distilled water. I have some pre-mixed soil right here. Mix it up, maybe about 50 grams of soil, until it's the consistency of peanut butter or frosting or something like that. A frosting knife is a good tool to do this. So we're going to take that soil and we're going to place a layer of that soil in the liquid limit cup. A flat layer of soil. Okay. Let's take a closer look at the rest of the test. Now, as you can see, I've made my layer of soil in the cup. I'm going to check it and make sure it's nice and flat. And I'm going to cut a groove in the soil using this. This is a grooving tool. So I'm going to take the grooving tool and I'm going to swipe it right down the center of the cup. One slow, steady motion, like so. As a result, there's a little trench in the center of the cup. So what I'm going to do now is I'm going to turn this crank at a rate of 2 cranks per second, and I'm going to keep turning it, and I'm going to keep counting the number of cranks until this crack closes up over a length of 1/2 inch. Usually, on most grooving tools, there's some dimension on the tool that is 1/2 inch. On this particular grooving tool, this dimension from here to here is 1/2 inch. So I can use that as a reference. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cranks. It took 12 cranks to close that crack 1/2 inch. Just to double check the results, we can repeat the test. Take the soil, make a new layer, make another groove, and let's repeat it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 cranks again. So, 12 cranks corresponding to this particular water content. So what we're going to need to do now, quickly, is get some of this soil, place it in a moisture content cup, and obtain its water content. So what we've done so far is we've obtained the moisture content of this soil corresponding to a number of cranks of 12. It took 12 cranks to close that crack, and we have a corresponding moisture content. The definition of liquid limit is the moisture content at which that crack closes at exactly 25 cranks. Chances are we're not that lucky to have it just perfect, such that at the 25th crank, crack closes, we're done. So what we need to do is we need to repeat the test at 3 different moisture contents, such that if we plot those 3 points, we can interpolate to determine the moisture content corresponding to 25 cranks. So what you'll do is you'll clean up your cup, you'll go back to your original soil, and you'll either add more water or add more soil solids. If you add more water, it's going to take fewer cranks to close the crack. If you add more solids, it's going to take more cranks to close the crack. So what you want to do, like again, is to be able to interpolate to get that 25 cranks. And if you plot the moisture content on the y-axis and the number of cranks on the x-axis on a log scale, you'll be surprised that those 3 points will fall in a straight line, and you'll be able to come up with the liquid limit. Seems kind of like an odd, archaic test, but again, you'll be surprised at the results. So now let's go to the plastic limit. The plastic limit is defined as the moisture content or water content, we use these 2 terms synonymously, the moisture content at which the material stops behaving like a semi-solid and starts to behave in a more plastic manner. So a good way to start it is to take some of your soil that was left over from the liquid limit test and make a little ball of mud, maybe about the size of a pea. It should be about the consistency such that if you threw this at the wall, it would stick. Don't throw it at the wall, but if you did, it would stick. So we're going to start there, and what we're going to end up doing is rolling this down into a rod and keep rolling it and drying it and rolling it and drying it until it crumbles. Let's take a closer look so you can understand better what I mean. Okay. I've taken my little pea-sized ball of mud, such that it's pretty soft, but it's not really sticking to my fingers. And I have a frosted plate. Now what I'm going to do is I'm going to roll it into a rod. And I'm going to roll it down until it is 1/8 of an inch in diameter. I'll know that it's 1/8 of an inch in diameter because I have a steel rod or an aluminum rod or some kind of rod that's 1/8 inch in diameter that I can use as a reference. So let's roll it down very slowly and carefully. And when I get to 1/8 of an inch, I can compare it to my metal rod. They look to be about the same diameter. Okay, now I've gotten to 1/8 of an inch. It has not crumbled yet. The soil rod is still intact. So what I'm going to do is I'm going to pick it up, roll it up into a little ball. While I do this, when I do this, I'm drying it out by handling it with my fingers. And I'm going to do it again. I'm going to make another rod. Now, I repeat this, and on the trial where the soil begins to crumble right before I make 1/8 of an inch, that moisture content, when that soil begins to crumble, that is defined as the plastic limit. So I'll repeat this. It looks like I'm down to 1/8 of an inch. Still no crumbling. So I'll pick up the soil again, thus drying it a little bit more. And I'll do it again. I think it's getting close. It's starting to feel kind of stiff and a little bit crumbly when I make it into a little ball here. So I think we're getting close. Okay. Okay, looks like this is crumbling. It's starting to crumble on me. So I'm going to take this material. It's at the plastic limit right now. The moisture content right there is the plastic limit. So I'm going to take it and very quickly put it in a moisture content cup and get its moisture content. The reason you have to do this so fast is that's a very small amount of soil, and the longer you let it sit here on the plate and sit here in the air, you're going to lose moisture, so you need to get it to a scale right away. So that concludes the demonstration of liquid limit and plastic limit of soil. Our next demonstration will be grain size analysis. We'll see you then. Thanks.